Welcome all. Um, figure, where's my mouse? I figure we can keep this relatively short because our brains are probably all fried at this point. We had long talks in the morning. I think mine went way over time. So I will give you back some of the time I stole by making this relatively quick. What I'm going to show you very briefly is just demo a new tool that we've been building out. It's very much in the process of being made and in being made such that it's useful to psychological scientists and other social scientists more generally. And I will just very quickly, oh gosh, it's so annoying to get this. I'll just very quickly walk you through it. So if you go to extempo.rocks in your browser, you can register for an account. When you register for an account, I will then have to approve you like manually because I only want scientists that I know and trust using this for now. So I can get, because it's not quite ready for prime time. This is very much like an alpha version. I'm still soliciting feedback, trying to understand what people need and want out of these things. But yeah, at that thing, after you've been approved, there's this generator interface. Let's actually zoom out a little bit. And here you can just, you can only do one thing at first, which is just make a random face. Out comes a random face. Over here is a little slide bar where you can see what the model thinks of the face along various different attributes, where 0 is the mean rating, and anything above that is more so, anything less than that is less so. These are like z-scores for whatever we're allowing you to see. And then over in the far left, it walks you through like what you can do, right? So for step 1, you can choose what you want to manipulate this face along. You can type. You can not type and just choose as you go along. So we can say, let's say gender. It thinks that this face is very female, very feminine, and we can like transform it to be, let's say, more masculine. You can also type here too. It only goes up to 4. So if I type in 8, it'll like default to 4. You could put in whatever number you want here though, whereas the slider forces you into like increments of 0.1 something or other. And then you can hit the transform button, and then everything grays out until the face is ready, and out comes the now masculine version of that face. So you can also control for up to 2 other attributes at a time. Now the math makes it so that you can control for as many as you want, but because of how entangled the space is, it says that it's the same, it's holding those constant. The numbers look right, but the images don't. So anything past 2 starts to look a little weird. So for example, you can control for, if we're more, let's try a different thing. So for example, if we want to do trustworthy, the original face it thought was this, so we can make it look more so if we wanted, and control for happy, let's say. And then it spits out a face like this. But if we don't control for happy, and we just morph along raw trustworthiness, the face looks much more smiley, right? So we're currently in the process of building this out. There's an API that you can access by going to gateway.extempo.rocks/docs. So this is like when you build with Fast API, you get this like automatic documentation of what's going on. Not all of these will be open to you, but many will be. But you got to authorize yourself. You gotta be logged in. And the way that you log in is you click on this button and it'll ask you for a token. What is the token? Well, back here, there's a little button called API token. And you can just copy that to your clipboard and paste that into here. And then you will be able to, you see it's done, and then you say close. And now the locks are like black and locked in. So if you can access it, you should be able to do so here. We're going to have API endpoints here, for example, for you to like batch generate a bunch of faces. So say you need 100 faces that are at level X on trustworthiness. And you also want all the predictions for that. We'll have an API for that. We'll have an endpoint for that very soon. Right now, it's just one face at a time because I wanted a demo to show you. But very soon we'll have more and more things. Down the road, we'll have sort of the ability to encode faces. We already have that, but I'm a little concerned about opening it up, because you shouldn't be putting up faces that you don't control, right? The rights, if you don't own the rights to those images. And I could just imagine some random person being like, oh, look at what this said about Oprah's face or something. And it's like, that's not what this is really designed for. This is designed for science. So yeah, that's the idea. Any questions, concerns, feedback, thoughts? Or you can also see in your profile here, you just have like your account information that you put in at the start, and you can always change your password if you want. I can't see your password, just so you know. All I can see is like this, and your password is hashed. So it's a one-way function. I can't even recover it if I so desire. It's not possible. Sorry, you were asking, Hanya.
Is there?
So that's yes, that's this. So for example, when the face is first generated, down here are all the scores for the original face. But we don't have it. I'm still thinking through the UX. So like after you transform this, right? So I can't see too well. So after you transform this, let's say along age, and I make it way older, the predictions and stuff we don't have updating yet. So we don't have you like exploring the space, right? All of these sliders and everything take the original face and then move it along that thing. It's not like this now is the center of that and you can go exploring through face space. I need to think through the UX for that, how we're gonna do that. But in the actual like API, if you use the API, you can just get back the predictions for this face that you made. Because the face has an ID, and you just ask about that ID, give me the predictions for that face. There's also a number of other attributes we have here. It's not the full set of 34 or 35 that we have. It's a subset that is less likely to get me. Down the road, we will make those more open to people. So yeah. What else? Be pretty simple. Oh, yes. Excellent question. Yeah, so in the PNAS paper, we did that for a subset of 10 of the traits out of the 34, but they were like, some were chosen because of their theoretical relevance, and others were chosen as sanity checks. Sanity checks insofar as it should be the sort of thing that like doesn't work very well. And it works like you'd expect. So if we make a face look, if we morph a face to look more quote unquote trustworthy, it does in fact make people think that the face is more trustworthy. Yeah, it just works for a lot of things. So yeah, if that answers your question. Yes.
For your, I guess maybe your like state representation stuff. Is it like, have you played with like the diffusion ideas and the latencies? So you can start adding noise and generating and try to reverse engineer.
No, we haven't done any diffusion stuff yet. That is an awesome next step. Yeah.
Is it more GAN based?
This is entirely GAN based, entirely linear models. I imagine we can get much better performance if we use funky nonlinear models and bagging and gradient boosting and whatever have you. But we start simple. Yeah. Yes, Nir.
In many of the demos you gave so far, whenever you put something for any scale, the stuff that comes out seems like uncanny.
Mm-hmm. Mm-hmm.
Do you have so you like validate that people's feel it's like a real face because they're starting for the natural face like with this photo one? I don't know that that's a face. I think it's like a weird computer vision.
Mm-hmm.
It does not look a real face or naturally face in any way.
Mm-hmm. Well, this particular one doesn't because it's got this weird assemblage over here. But if we did like another one, say, right? This is pretty far along things. Let's make him.
It's pretty better, but I feel like it like a few times we guess like trustworthy like
Yeah, if you go extreme, it goes out of sample, right? So I don't make any strong claims that like if you crank up the dial all the way to 11, this is still gonna work. It's just that
dial. field would be judged by raters.
It depends on this. It depends on the starting face. It really depends on the starting face. You can go with your intuition, but that's why this was between -4 and 4. Anything past that is usually out of bounds. -3 and 3 is definitely safe. So the almost always safe. But I figure we can do this. So if we go like -2.625 or something. Oh, I think, I pressed generate by accident, sorry. If we make her, let's say, more smart, we can go crazy. We could go up to 4. I still think that this looks like a face, right? Yeah. So it depends on what you start off with. Like your mileage may vary. It's true that these faces can become what I call deep fried pretty quickly. They go out of sample. But that's okay. Just do some curation. Don't use the weird faces. Don't intentionally try to make people upset with you.
I mean, that experiment, I look like do a sparse sampling of multiple dimensions.
Mhm.
The whole idea is take the judgments away from themselves.
Mhm.
Relative to someone who has done the legwork,
Mhm.
what makes sense to take those spaces.
Mhm.
But then if I need to reapply my own, like, I don't really like that face. And I need to.
Well, liking is you shouldn't be putting your judgment of like liking on it, but your judgment of, does this look like a plausible face?
That's what I meant by like,
That seems reasonable to me to be fine for stimulus curation. Like, is it a plausible face, regardless of how much I appreciate this face or how much I think it's aesthetically pleasing? Once it doesn't look like it has some weird artifacts, you know? Yeah. And you do this even with like regular faces from existing data sets of real people, right? Sometimes you realize, ooh, this face, like their shirt is like put on in this weird asymmetric way, or you might think, this person has like a very salient facial feature that like can distort people's impressions of it.
doesn't distort that. That's what like introducing experimental biases.
I mean,
Like the stuff that thing going.
mhm. Yeah, I think it depends on your use case and what you mean by experimental biases. I think that you can't get away from any and all biases in all cases. And that's true even if you use like curated stimulus sets, because the stimulus sets have been themselves curated by experimenters. And this was, designed, or rather the original base model is taken from Flickr, right? So Flickr, that's reflecting the biases of the photographers out in the world, right? Mostly Western photographers. And then these models reflect the biases of the like mostly American, mostly white sample that we have. So there's just biases all the way down. It's turtles all the way down. But if understanding the bias is the goal, then it can still be useful. It depends on what you want to do. Yes.
So I guess like an interesting thing that I think relates a little bit to some of the points you were making, and also about your point about the controlling for multiple things. I'm assuming that parts of the trait space are highly collinear and other parts are more separable.
Mhm.
And how does that manifest when you're doing the adjustment? Because it seems like you're putting in the units of standard deviations.
Yeah.
But if you don't have, if things are really, really tightly collinear, you may not be able to really fully ever separate it, even if you are able to do it. So I mean, so you get more distortions when.
Yes. Yeah, definitely. Absolutely.
And I guess like what's the like I like what's I don't even know like really what's the right way to deal with it. So on the one hand, you're like, okay, well, we could find a way to maybe like subsample or interpolate in when they're really collinear to try to like fix that. But then you're giving people a false impression that these things are like more orthogonal.
Correct.
When in practice, many of the constructs may not be orthogonal at all.
Correct.
And I don't know, you know what I mean? Like, so it's like, is the covariation important, but then are we getting a false sense of control? Like,
Yeah. That's why I try to put all these caveats, right? That these impression dimensions are extremely holistic. They operate on the image as a whole, including changing the background properties of the images. And many of these things are going to be collinear and have their representations overlap. So by controlling for one thing, you may actually be like removing the thing that that makes it what it is, makes that dimension what it is. So yeah, it really depends. I feel like that it's in and of itself could just be its own like dissertation, you know, exploring the space, what it means, what are the actual underlying dimensions of impression formation. I don't know. I just can do funky things with faces. Okay.
Structured manifold of embeddings as opposed to like inverse graphics approach where you give it a bit more structure, and then like what you're learning is how to manipulate the like latent features of that generative model. Like why learn the pixel statistics instead of constraints on a physical model of facial features and skin and lighting.
A couple of reasons. I mean, mostly because of path dependency, I'll say, right? It's about what is within reach for me to do. So I was in Alex Todorov's lab, and Alex is famous for having made these statistical models of faces using FaceGen, where FaceGen is its existing face space that you can morph faces along, 50 shape dimensions and 50 reflectance or color or texture dimensions, whatever you want to call them. And then just by having people rate random faces within that space was able to produce this very useful, informative, mostly two-dimensional space of trustworthiness by dominance. And I thought it would be a nice first step to just apply those exact same models to a very different kind of space. So the exact same techniques, I should say. So by sampling from this latent space, all sorts of random faces, and having people rate those, we can now vary these images along that space. So it's mostly just like it's not because I thought that this was the #1 best way to possibly accomplish this goal of making realistic and diverse faces, is because it was what I thought was achievable and within my reach and would work, and would be a nice sort of like narrative in a way, where it's like you can still use these cool models from 10 plus years ago, or at least the same techniques as applied to these latest state-of-the-art GAN-based models, which at the time they were state-of-the-art. These were the best ways to make realistic, diverse faces. So I thought, oh my gosh, we can now make like these realistic, diverse faces while still manipulating them along these trait impression dimensions that people in the literature care about a lot. So do I think that like there are way cooler ways to do this, and it would be awesome to have explainable, better like face pull models where you can really dig? Of course I do. But that was not within my reach as a postdoc circa 2018, 2019, 2020. Now, if I get a cool postdoc that could do what you're suggesting, then yes, hell yeah, let's do that. But I have to acknowledge my own limitations as well.
Thanks, Stefan. Looking forward to all having our ex-tempo accounts approved.
Yes, for sure.